Hey everyone, welcome to class today. So in this particular lecture, we're going to be going over the midterm, all of the answers, all of the R code for a very specific reason. I want to make sure everybody's on the same page in terms of content, in addition to the fact that I will not be curving the exam, and I'll tell you why. So when you're curving an exam, you're kind of normalizing the exam grades on a bell curve, which usually if you have a high density of people at the bottom of the bell, in theory, of the bottom of your distribution, right? So a lot of people did poorly, it pulls people up. Now, it also has some heavy repercussions for people that are on the high end, right? Because it would mean that it would drag some of them to the center as well. So people who did really, really well would get kind of drug into the center, or people who did really poorly would get drug into the center. Now, we had a lot of people that did really well. They got a lot of high A's, some perfect scores. And so in this case, we did not have a super high density of people that did poorly. We had a lot of people that did average or a little bit below average, usually because of the fact that they got all of the R questions wrong. And so by normalizing it on this sort of bell curve, we would be penalizing the large group of students who did really well, which does not seem fair. What does seem fair is giving you guys all of the tools to actually implement the code from the R section of the midterm, allowing you guys to retake that section, the people that got zeros or under, let's just say under 3 for any of those R questions, and allowing those students to do them for partial credit. And I think this is fair because I'm going to give you all the code to do it. Your job is just to get it running. In the case of like the Z-score question and the mean questions, I'm going to give you all the code. You just need to copy and paste the variable that you had originally chosen into those answers. It should be pretty straightforward. And this also is a chance for you to get this R stuff kind of up and running before we move on to the next part of the course, which is going to be very R heavy. And so this is a moment where we really kind of need to get everybody on the same page. So there's not going to be a curve, but there's going to be plenty of opportunities for you guys to make up the points that you lost in that section, in addition to the fact that I may offer extra credit later on in the quarter. I'll kind of play this by ear based on how people do in this section. But I do want to make sure you guys all do well as best as possible. So I think this is the fairest method, though, given how many people did really well on the exam. Okay, so we are going to start by going through all of the like written answers for the exam and the multiple choice, and then I'll go through the R code. So let's go ahead and look at that. So we have different foreign policy events as our variables in the first question, and in our observations, we have number of airplanes used, whether the country is in the Middle East or not, and the number of ground vehicles in the operation. Ideally, looking at the airplane variable, you would have noticed, or the airplane row, you would have noticed that there's 35 as compared to 2, 5, 4, and 4 in this case for the Iraqi airstrike. And so in this case, it is an outlier. So really, you should have been doing the median. So the median, when you kind of go 2, 5, 2, 4, 5, 5, 3, 2, 4, 4, 5, and 35. So you put everything in numerical order and cross out, you get 4. So the median is 4. I also accepted for full credit the mean, though, for airplanes. So this is how you get to the mean, and the mean was 10. We know that the modal response for Middle East was 1, which means that yes, it was in the Middle East. There's 3 in the Middle East, 2 that aren't. So the modal response is 1, or yes, in the Middle East. You also should have calculated the mean for vehicles, which is 4 plus 1 plus 3 plus 2 plus 5 divided by the total number of variables, and you get 3. So measures of central tendency were all you needed for that first question to get full points. Now, the second question was about Z-scores. So I gave you the standard deviation here and here in the question. And then you just needed to plug in the variables or the additional observations that you needed. So in this case, for Yemen, the number of airplanes involved was 2. So 2 minus 10, which is our mean, divided by the standard deviation is -4. Because this is negative, we know that they're in the lower 50%. So Anytime it's negative, a z-score, it's lower, right? Lower than the average. The z-score for the Yemen raid on the number of ground vehicles is 1, right? So the number of ground vehicles in that case is 4. The average is 3, and it's divided by our standard deviation, which is 1. Because it's positive, we know they're in the higher 50%, right? They're above the average. But relatively, they're more average on ground vehicles than airplanes because 1 is closer to 0 than -4 is. So that's how you get through the first 2 questions. Let's go through our written variable operationalization and our short or multiple choice. So in this case, this question was asking whether or not or how you should measure stress. There were a few different ways you could do that, but you had to respond with 2. There was a lot of people that put things like interviews, which is fine, but you didn't get any details on what that interview would look like. And so I took off some points for that. Ideally, you would have given me concrete measurement tactics. So you could say something like measure stress on a scale of 1 to 5. You could use a binary measure, whether somebody's stressed or not. A lot of students did some interesting things like physiological markers of stress, blood pressure, sleeping habits, all that kind of thing. You could also do something like whether or not they sought therapy. These are all things you could also uncover in an interview, but because you're not actually operationalizing the variable, you lost some points there. There were some students that got this one wrong. So for my research, I happened to be in Washington, D.C. on January 6th, visiting the Capitol. When the insurrection occurred, I took out my notebook and started counting certain things that I saw, the number of women, the number of MAGA hats, the number of QAnon shirts. What kind of data is this? It's quantitative because they are counts. There were some people that said qualitative because it was like observation, but it's observation of quantitative data, right? Their counts. For the next question, which of the following best describes the scientific method? So it's the method that researchers use to structure an academic study systematically. There were some other kind of trickier answers in there, like things that sounded right, but they'd say only for quantitative data, and the scientific method is for any sort of like empirical data collection. So quantitative or qualitative. So this was the best answer out of the bunch. What is an example of an R function? Almost everybody got this one right. The dead giveaway here obviously is going to be the parentheses, and we also use the sample function in our lecture on the object orientation of R. So if you're struggling with that at all, go ahead and check that back out. The other options in there, either packages, right, which packages are an amalgamation of a bunch of functions, or they're just kind of like R terms. Which of the following is the best example of a null hypothesis? The fact that there is no relationship between our 2 different concepts, right? When there is no relationship, dead giveaway, it's a null because it's obviously going to be the alternative of whatever theorized hypothesis we have. The next question is, my original hypothesis suggested that income affects party ID. I confirmed the null. Addition, I found that income affects a third variable, education, which also affects party identification. Because income is also affecting education, and education is affecting party identification, this third variable is an intervening variable. The only other way I gave you some partial points is if you said confounding, because that's kind of like the umbrella term for all of these things. So I gave you some partial points if you got that one. But intervening variable was the best choice. Most of you got it, but it required you to go back and look in your notes. So there were some people that didn't get it. So when we have an interval ratio variable without an outlier, what's the measure of central tendency that we use? It's the mean, right? The alternative of that with an outlier is the median. I chose to measure political ambition with a bunch of different categories. We know that because it's a category, we have to use mode. Which of the following is a correct statement in describing negative z-scores? The negative z-score is always below the mean, and a positive z-score is above the mean. So we do know that because it's negative, it's going to be below the mean. All right, so our part 1 actually could have been mostly and almost completely completed with just your code book, right? So this was also a test of whether or not you're paying attention to the information that's been given to you, right? So the code book is always super helpful in terms of sussing out what what's going on in your data set. And so this could have been completed pretty easily on its own. So there are 628 observations in the data set, 30 different variables. And I'll show you how to see this quickly in R as well. The different observations were different counties and the electoral information for each counties. The urban influence code had 9 categories. And for the variable competitiveness, what were the different categories? And why would they be helpful to a political scientist? So it's competitive, semi-competitive, non-competitive. And it's just helpful to know whether or not they had a close election to study a phenomena, because not close elections are not necessarily as helpful for us, right? If the incumbent knows they're going to win, it's not necessarily as like electorally interesting. Vote stem is interval ratio, and then according to the county type, what's the modal response? So this is the one where you had to kind of move into R, but I'll show you where you can find these in R, and then where you could find these in the code book. Okay, so let's say counties, you could look here, right? This is one way to see it, by county. Okay, so that was one hint. You can also just look at the data itself. The urban influence code 2013, you could roll in here. Urban influence code, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. And then after that, they start to go to unknown, right? So there's 9 that are like known categories. Vote stem is one of our other ones. It's the number of voters, so we know it's interval ratio. And then the modal one, we'll go back and we'll show you how to do this in R. But there was a lot of this that you could have got at just at the code book, right? Which is helpful. Okay, let's go to R. All right. So let's do another quick recap on what to do with RMD files. Okay, so say I give you an RMD file. You open it in R like you'd open a file in any other program. So it's file, open file, and then I don't think you guys will see this, but it'll come up with whatever browser window you have. And you can open it up out of your downloads or whatever, and then it'll open up this. So file, open file is how that works. When you want to turn in an RMD file, you click save, this little save icon here. And then you would upload it like you would any other file. You don't have to knit. If you actually looked at the details on the RMD file that I gave you, you would have seen that it said don't knit that particular one, because you were going to have some functions in there that weren't compatible with knitting. But that's kind of the overview here on how to do the midterm code. And remember, you import your data in the same way we have been doing, but remember this was a CSV file. So you had import from text base, and then it would come up the way that it shows in the thing, but you won't be able to see all that stuff from this pane. But yeah, so importing the RMD is open file, importing the data sets down here. Okay, so as a reminder, this mode function is a little bit different than the ones you guys have, but it does the same thing. In order to actually make sure that I have this function for later on, I need to run it. This was given in your helper file, so you should have that. You know that it ran and that you have the mode function in there because on the right-hand side, it says functions mode, right? So this environment is really helpful in terms of knowing what you have going on. And so we know that we have a function called mode that has all of these things in it. You have to have this, see this bottom bracket? If you don't have this bottom bracket, it will not run. So see when I click this bottom bracket, it's matched by this one on the top, right? So if they are matched, then it'll get highlighted. If there's not a perfect match, it won't run. And it'll just kind of try to keep running and you have to kind of manually stop it. So this is super important. Another thing to note is if you look on the right-hand side in your global environment, once you've imported your data, right, you have this line for your midterm data that shows you have 628 observations with 30 different variables. That's one way to look at it. We also can do something like from the B-ball lecture, dim and dim of our midterm data set. Midterm data. So if another pro tip, if you ever kind of get to this point where it gives you this option, if you click tab, it'll autofill for you. So I definitely recommend using the autofill function. So if I run dim midterm data, I see that there are 628 observations with 30 different variables. So there are a couple different ways to get in that. Again, you can also view the midterm data, view midterm data, and that gets you to this pane, and you can see that our observation level is the county, the different county names. So there's a few different ways that you can get at that. But again, I think the code book was probably the easiest way. Before we move on to the next question, let's just get the mode in that in the end question for the first R one, which is what was the modal response for Metro. In order to do that, I would use the mode function. I would select out of the midterm data with the $sign the variable for county type, all right, which is the one we were talking about. And the modal county type is non-metro. They were metro or non-metro, and the most common one was non-metro. So this is how the mode function works. Your mode function probably says get mode, right? Because it's a little bit different, but it runs the same way. So use your get mode function. It would look something like this, get mode, and it would work the same. Okay. Moving on. So I thought maybe I'd just show you what it looks like to do the calculations in R for your handwritten stuff. So for airplanes, I made a vector that had all of the different columns, all the different values for the observation per column. And then I can do the mean of airplanes, which is 10. I could have done the median of airplanes, which is 4, or the standard deviation of airplanes, which is 14. You didn't need this for your exam, but I'm giving it to you. And so the standard deviation that I gave you for the actual exam was a lot smaller because the interpretation's a bit easier. It was without this sort of outlier. Okay. Another function I want to plug at this point, just to see if you guys are interested in it, because we made this thing called airplanes, we can use the scale function, and the scale function actually just drops all the different z-scores for each one, for 2, 35, 5, 4, 4. It does it for each. It also gives you the mean and the standard deviation that it used to calculate it. So for the midterm data, if we wanted to use something like this, we could do midterm data and then maybe like, let's say vote dem. And so this is going to be a really long list because it's a long set of variables. You can see what it would look like, right? So for our third row, if you use the variable vote dem, the z-score is negative 0.277. So just another kind of function plug for you guys to be able to use for z-scores, but I still recommend using that mutate function. There's been a little bit of struggle with getting the pipe. As a reminder, if you want to use a pipe, you need to load the tidyverse library. So library tidyverse. And this loads the package within it that has the pipe function. Okay. So for vehicles, I made an object for vehicles, and I can get the mean, standard deviation. I could also get the median if I wanted to. Let's do that too for continuity. And it's 3. Cool. So in this case, fun, the mean and the median are actually the same, which happens often when there's not skewed data or there aren't any big outliers. So all right, so let's go to the second set of our questions. So say we had a hypothesis that counties with higher poverty would have a higher percentage vote for Democrats. Now, the point of this code is for you to copy and paste the variable that you're using and plug it into this. And so this may not be the hypothesis that you used, but you can go ahead and use the original hypothesis you had and drop in the variables that you want. There were some people that I feel like had chosen interval ratio, non-interval ratio variables to get out of calculating with z-score, which isn't it isn't a wise way to do that. I didn't give points mostly to those folks, right? So make sure you have 2 interval ratio ones so you can actually calculate the z-score. So say I wanted to look at the mean of, so PCT, POV, ALL, so the percent in poverty in 2018, the mean percent in poverty was 14.76, and the standard deviation was 5.6. So I'd place both of those things in my midterm. The mean for percent Democrats, so the percent of people that voted for Democrats, was around 30%. Or 30%. And then in this case, the standard deviation was 14. So these are actually at different units, but that's okay for our purposes. So the mean was 0.3 and the standard deviation was 0.14. Okay, so this is the code for when you needed to create a hypothesis, pick two different variables, and then get the measure of centrality and the standard deviation, or the measure of variance that you had to do. Okay. So we then needed to calculate z-scores. So we're going to pipe in from our midterm data. Remember, you have to have this pipe, the mutate function, where we're going to create two different z-score columns. The first z-score column is going to be the percent in poverty. So every observation percent in poverty minus the mean for that column divided by the standard deviation of that column. You make sure you put a comma before you make your next z-score argument. And then we're going to do the same thing for z-score 2, which is percent dem, all the observations percent dem minus the mean for percent dem and the standard deviation for percent dem. Other than not using the pipe, one of the other things I really commonly saw was people losing a parenthesis or losing a bracket or something like that when they were copy and pasting. And then the function doesn't work if the brackets are mismatched, right? So say I accidentally deleted this. So see, right now it's highlighted. I have my cursor right here. It highlights the back end. We know that that function is closed. If I got rid of that, it should, in theory, give me a little red X, and I can see that it's not going to work because the thing's not closed. So if I tried to run it, it would not actually finish, right? Because I didn't close it. So I'd have to do something like throw in another, try to close it now, and then it will throw an error code, right? Because I didn't close it originally. I put it back, I run it, and it goes. Okay, so let's look at what those z-scores look like. We go to the end. We have two columns for z-score. We needed to find for that third county. I think the language in the midterm said person, but it's counties, right? So that third county for percent in poverty, the z-score is negative 0.08, so it's below average. The z-score are like in the bottom 50%. In addition to the fact the z-score for percent dem is also negative at 0.55. And so in that case, it's also below average. So the interpretation on that question depended on what variables you chose. So I'm going to give you this file. The goal is to get everybody on the same page in terms of the code mastery they should have, and also give the people that totally missed those points on the exam the opportunity to get some of those points back. If at this point you have problems with the code, or it's not running for whatever reason, or your R is not working properly, you need to reach out. And there's only so much I can do in an asynchronous class with keeping track of where you guys are at. And it kind of in part depends on these moments where you have homework and graded assignments, and then you guys reaching out to tell me that you're struggling. We have a lot of people that are doing really well, and also some people that maybe don't quite feel comfortable asking me questions yet. That's definitely what the Discord is for those of you that have gotten used to asking me questions there. I try to get back as quickly as I can, given all the other things I have going on. I try to monitor it a lot. And so at this point, this is kind of like a come to Jesus moment, where we're all going to kind of get to this same point with our proficiency, is my hope. Because the rest of the course and inferential statistics we're going to want to use R, because it makes it so much easier than doing things by hand. Doing things by hand with these big data sets is near impossible, right? So we want to have this, think of R as the calculator. You want to have the calculator at your disposal. And if you don't, things are going to get really challenging. So there's all this to say that I now hope you have a better understanding of what was expected of you on the midterm if you feel like you didn't do that great. In addition to the fact that you'll have the code that you need in order to move forward if you didn't do all that well in those questions, and you can attack them for partial credit. And I think the deadline for that partial credit will be next Monday, but I will keep you guys posted on that front.